Well, um, today we will continue our theoretical lecture as well as some practical part, which we need to have the code with MATLAB in the practical part. But before that, what I feel that some definition is maybe mixed in your mind. That for the first 2 day lecture, I'm going to clear it, and in the second lecture, we will work with the some sample code, which in that you can test and see some result. Means that having the some coding skill for this theoretical definition. Then today we will talk regarding the concept of the uh, convolution, and then we will go till end of first lecture part. In the second lecture part, we have 9 or 7. I'm not remember exactly. I think 7 example, which in that we are going to test and speak very limited word about the previous concept that we have. Um, you know that for the second lectures, our aim is that to have the skill to analyze the theoretical part that we teach. And slowly, we are going to analyze the programming and result. Okay, but we should have some theoretical part. We should have some knowledge to do that, which I try to give you all this information before. Along with this, uh, in the next lecture of this week, second part, Roy will talk about his project for us. And from next week, in the second time, each lecture we have 10 minutes talk from you, which is your some part of your midterm exam and your task. And you should start to send me the PPT. Means that the first person from next Monday, which I give the date on the table, should send me the PPT before our next lectures, and I should see his PPT, give him some advice, which part he should make better, which part is weak. And then if you lost your time, means that you couldn't reach the time for that PPT time, you already failed from that portion of the meeting. We don't have any rearrangement for the time, unless that it will be something that we cannot handle it. Otherwise, now all of you know your time, your date, then please make ready and do your task based on the time that I give. Even if you can send it sooner than that, it's much more, I think, better that we can arrange. Okay, let me start for today lecture. For before second part also, we will talk more regarding this task because still some student didn't join us. Anyway, there is two words in this image processing, especially the digital image processing, or on the other words, if I want to tell you this image, we have the some view like signal, any type of signal. Why? Because some theoretical part, some mathematical part that we are hired to use in the image processing part. It's very similar to the signal processing. And even there is one subject that people call it DSP or digital signal processing. And same action that we are act on the image is same as what we will do in signal. Then other view to the image can be some similar concept to the signal. Anyway, then in this, we have two words which are very near in somehow and very far from other side, which they are correlation and convolution. Correlation and convolution are known as the basic operation. It will give and perform to extract the information from the image. And in some sense, the simplest operation that we can perform on an image, but they are extremely useful. Moreover, because they are simple, they can be analyzed, understand, and understood very well, and they are also easy to implement and can be computed very efficiently. Theoretically, convolution or linear operation or signal modifier, whereas correlation is a measure of similarity between two signals. And in very brief, this is the border that we have with them. And we know the convolution as the linear operation and correlation as the similarity between two signals. Image convolution, if we want to discuss in deep, which is the main topic of today, we can say that before we discuss this and speak regarding that, and as image is the signal is nothing by two-dimensional signal, means that we know the image as the two-dimensional signal. And we have discussed that in image processing, we are developing some system whose input is an image and output also would be an image. This is pictorially can be represented as something that I have here. Suppose some 3D world that we have around us. We will capture it with camera and convert it somehow to the 2D, and then we will do some digital processing system or particular system to focus on some specific job. Here, suppose the aim for this image is water drop, and then suppose we want to zoom it, then we will zoom or process the image at the end. It can be some image processing process. Uh, Maybe this is not the bad idea or good idea that we can have all this system as the black box. Is that in this box, which is shown, we can label it as the digital image processing system. And then we have image as in the input and image at the output side. Till now, two important methods of manipulating image we have, or in the other words, we can say that our black box can work on two different ways. One was the graph or the histogram, that this method is known as histogram, and we have discussed it in detail in previous part that we have about image enhancement and brightness that we work on that. And on the other side, we have another part that we will discuss. But before that, I wanted that you know that we have some transformer function, which is this method. We discussed this different type of the transformation and many grade level transformations. Suppose if you can see from the figure that I show, we will do some action on the input signal. It can be image or signal, and give the output based on the transformation method. Okay. Another method that we will dealing with the image is something that we will talk today. We know it as the convolution, and we know it as the convolution part. This convolution is the other method, which is usually will work on our black box as it, and we know it as the LTI system. And this LTI system we know as the linear time invariant system. Linear time invariant system are the signal which output and inputs are changing based on the time and with the linear method. Linear in the sense that when you change the time, you have the corresponding output based on this changing in time. And by this linear, we mean that such system where output is always in linear, neither it can be log or neither can be exponent or any others. And by time invariant, we means that a system which remain same during the time. Remember this in your mind. Then, if I want to represent this black box for me, I mean the convolution part, I can show it with this form. JXY can be performed by the two signal of HXY and FXY, which are will be convolute with each other. Other way to represent this information is that, or it can be explained by the mask convolved with an image. Okay, um, you know that I can change the place of the H and F to means that vice versa means that H multiplied by F or convolution. This is not really multiply, but we can say okay multiply or F convolution with the H. There is no difference, and both way are represented, and we know this star as the convolution operation, which really will do with the mask or filter of HXY. Let me tell you more clear. Think that your image is stored in the fx and y function. Now, if you want to filter it, you should do the convolution with the h, x, and y. Okay, means that this h, x, and y is your filter or is your mask that can perform on the signal. This may be a little bit math I should give you that this convolution also can be defined as the below formula that we have, which in that really or in the real mathematical lecture, we can show this f star x or f convolution or as the integration between minus infinite to finite and the change that we have on the function of f and j. Then these can be means that we can show it as I said before f convolution by J and J convolution by F. This is just very brief mathematical things that I bring. That was in 1D, then in the 2D, you have two integration. And if you have the effect of just A in 1D, in 2D, you have again effect of B in your integration. And it's also same that Fx and Y in 2D is same as 1D means that you can again change the place of them. As well as here, now you are open to the two variable of U and V uh, in the convolution side. That was very brief on the mathematical section. And now, in theorem of that, we can say that convolution is in the spatial domain which is equal to multiplication in the frequency domain. This is the whole idea in convolution in any subject. In signal processing subject or in digital image processing or in the math even subject, it has the fixed formula that now you go from the spatial domain which is equal to the multiplication in the frequency domain. And it's very useful because this multiplication is the spatial domain and is equal to the convolution in the frequency domain. Means that if you have something in the time domain, then you can convert it to the frequency domain. Just you can multiply it and then do the same job that you can do in the time. Then, okay, we understand what is the theorem behind the convolution. Now we should say why we need convolution. Convolution can achieve something that previous two methods of manipulating image cannot achieve. Those means that the before ones are include the blurring, sharpening, edge detection, noise reduction, which are very useful in the image processing work. Then with this convolution, we have the mentioned ability. We can use it. Once more, let us see what was a spatial frequency. Is that convolution filtering is used to modify this spatial frequency characteristic of an image, and we have zero spatial frequency, low spatial frequency, and high spatial frequency. Don't forget these words. And now, with this info, if you want to review once more what is convolution, we can say that convolution is general purpose filter which effect for the image. Then let us, not very official or very technical word, but have it in your mind that convolution is our filter, okay, and will act as the filter on our image. Today I will show you some type of filter, but noise. But anyway, more we will talk later on that. We can say that it's a matrix applied to an image and a mathematical operation comprised of integer. This convolution is worked by determining the value of the central pixel by adding the weighted value of all its neighbors together, and the output is the new modified filter image. We know the convolution as the simple mathematical operation, which is fundamental is to many common image processing operations. Convolution provides a way of multiplying together two array of numbers, generally of different size, is more important, but with the same dimensionality, to produce the third array of the number of the same dimensionality. My friends, remember this having the same dimension. It's more important. And even if you want to do the convolution of the two image, you should mention the same dimensionality. This can be used in image processing, I mean convolution, to implement the operators whose output pixels value are a simple linear combination of certain inputs pixels value. In an image processing context, one of the input arrays is normally just a gray level image, and the second array, remember fxy and gxy. Fxy can be the gray level image, and second is the gxy is usually much smaller and also two-dimensional. It's also maybe just a single even pixel thick and known as the kernel. Then now we learn something new. In the convolution, we have one term, which is the input array with the form of the gray level. And second is the term, which is mainly is 2 by 2, and it's in the name is kernel. Now let us figure what we have about the image processing. Now you will see we have two matrix. One is I, another one is K, which I want to show you how the convolution will act on this. You will see this 2 by 2 is one is the kernel in the left side, and then, sorry, in the right side of mine. And the left side is a small image, and the label which will shows the each grade square or has identified the, the data. Means that HII is one pixel on one part. It can be the gathering of the pixel that we have there. Then they have some specification, each place that you can see on the matrix. Let us see it better. Now maybe it become more clear. The upside, I have kernel matrix, then I have one input image. Then this kernel will go and act something like a stamping, but not real stamping. Stamping is not a technical word, but something like that we can assume. That it's go and put in each dimension of my array, and then we have some summer, and then we will do the scaling contents, and then you can have the output image here. I even show this part here below as the uh, convolution part. The convolution is performed by sliding this kernel over the image, as I show, and generally starting at the top left corner. From that, it's going to sweep. So to move the kernel through all the positions where the kernel fits entirely within the boundaries of the image, not the implementation occur in what they do at the edge of the image and explain. Each kernel position corresponds to the single output pixel, and the value of which is calculated by multiplying together the kernel value and underlying image pixel value for each of the cells in the kernel, and then adding all these numbers together. So in our example, the value of the bottom right pixels in the output can be given something like that. O as the output, then I57 multiplied by K11, 58, K12, 59, 13 plus 60, 67. Like these, each part of my main matrix or my main image will be multiplied by my kernel side, and then the output of that part will create. If the image, suppose, have the m row and n column, and the kernel has m row and n, like this, capital and n, please note this part, then the size of the output image will have m minus small m plus 1 in the row, and n caps minus n small plus 1 columns. Then mathematically, we can have the convolution as below formula, as OIG, and which runs from 1 to caps m minus n plus 1, and j runs from 1 to n minus n plus 1. Simply, the idea we understood that one kernel is acting on any place of my image. Let's talk more regarding this uh, concept. I mean, this important and even much more nice uh, concept, which in that many implementation of convolution will produce the larger output. And these because they relax the constraint that the kernel can only be moved to position where it fits entirely with the image. Instead, the implementation typically slide the kernel to all positions where just the top left corner of the kernel is within the image. Therefore, the kernel overlaps the image on the bottom and right edge. One advantage of this approach is that the output image is the same size as the input image. Remember that. And unfortunately, in order to calculate the output pixel value for the bottom and the right edge of the image, it's necessary to invent the input pixels value for place where the kernels extend off and end of the image. Then some place will remain. And typically, pixel value of 0 are chosen for region outside the true image, but these can often distort the output at this place. What I mean that when we want to do this kernel multiplication, some part of our image which are in the border, they may remain. Then what we should do with this? Therefore, in general, if you are using the convolution implementation, it's better to keep the image to remove this series region. We should carefully select the region and removing n-1 pixel from the right hand side and m-1 pixel from bottom will fix this thing. Convolution can be used to implement many different operations, particularly special filters and feature detector. Remember, these are the applications that we will use. Some example we will note it now, and then we will see, I think in this week, next lecture of this week, about the MATLAB performance on the image. Then that time again, I will remind you this, but anyway, keep it in your mind. Some example, we have some Gaussian smoothing and Sobel edge detector. More description about this I will give you, don't worry. But now let us see as a brief here. In Gaussian smoothing, which is operate a 2D convolution operator that is use the blur image and remove the detail and noise. In this sense, it is similar to the mean filter, but it uses the different kernel that represents the shape of Gaussian, something like bell-shaped hump. And this kernel has some special properties which are detailed below. Means that you have some um, bell-shaped hump, and in that you can have the smoothing. Means that you see this shape, figure will come here, but smoothness will happen as the output. And with the Sobel edge detector, which is again a 2D spatial gradient measurement on an image, and so emphasize the region of high spatial frequency that can correspond to the edge. Typically, it's used to find the approximate absolute gradient magnitude of each point in an input grayscale image. Have these two in your mind as the application of the convolution. I took this part of the lecture from the mentioned homepage, and in that there was even some more nice topic that you can find. But I thought that if you know this idea, it will help you to have more and better um, analysis for future lecture that they have. That is why I put the first part of our two-day lecture about convolution and how it will work. Then we can uh, continue our topic. Now, please turn on your webcam that we do the first assignment of first lecture part. For first lecture part, I think it's okay, but we will do that. And what we are going to do in the next part of today lecture is that we are going to work on some yes, we don't have a screen, just wait. I should manage it because some part we need PPT and some part we need MATLAB. Okay, my MATLAB is run now. You know that mainly it takes some time for us to come up. Anyway, yes. Now you should have the image. We will going to review on some previous concept, but now with the MATLAB vision, till now we talk more about theoretical of that, but we slowly start to test some of them. I want that whenever you will repeat my experiment, which is the task for you for today, you should repeat them. When you will repeat, test with different image. Somehow you may have error, but that error will teach you so many things. Suppose for today, for your filtering part, if you use some other pictures, maybe it will not work, but read the error and try to understand why that error happened. Sometime for the size of the image, sometime for the type of the image. And these are the inputs that you should have some experience about them. And then by these, you can see that, okay, what was the problem? And then the analyzation, means the mathematical analyzation part, will come to picture and the studying process become faster. Please do that. What I cooked for today is that we work first on some pixel, and as you remember, we had some pixel neighborhoods, which is an important measures in images, and is the concept of connectivity. Is that in pixel neighborhood, we have the concept of connectivity. Many operations in image processing use the concept of local image neighborhoods, and it's used to define a local area of influence, relevance, or interest. Of central of this term of defining the local neighborhoods is the notation pixel connectivity. For example, deciding which pixels are connected to each other. Suppose when we pick for connectivity, only pixels which are north, west, east, and south of the pixel will be connected. However, if in addition the pixel on the diagonals must also be considered, then we have 8 connectivity, for example, north, northwest, west, northeast, southeast, east, southwest, south, all are connected, then you can see in your picture. Then if we want to test this program, means that to see some example of that. Now I think you should not see. Wait. Today I think I should always ask that. Today I should always ask that. Can you see my desktop or no? Anyway, let me see. This is my MATLAB desktop, as you can see, and now we go to test some concept regarding this connectivity. Yes, now it's gone. Okay. See this code. As usual, first I start with the CLC and close all and clear all. In the second line, I read an image and then I do the subplot and show the A. Let us just test it this part. Can you see the screen? Just one person give me feedback, please.
Yes, sir. Yes, sir.
Okay, good. Thank you. If I evaluate this, till this part, it shows me that cameraman. There is some reason that I select this image. Because this image is, I don't know, can you see the figure or again I think. Figure, can you see?
No, sir.
Okay, wait, I guess that. What should I do? Just wait. Okay. I already shared my desktop, but when the MATLAB will generate the output, it will not show you that. That is the problem, because the output will be changed. Now you can see this image, I think, is cameraman. In this
Yes,
cameraman,
sir.
just what we have done, we open it, and then in the next line of that, I'm going to set a filter to apply and take 3 by 3 neighborhoods of that. Then image. Now, let us see what will happen with our image. You will see that if I take the 3 by 3 neighbors of my image, little bit the figure become blur. Can you see? Compare with the original image, we can say that somehow the main image is uh, corrupt, or there is some problem with that. Okay. How I have do this? Let me again come back to my, yes. Now, if you see my code, I think now you should see my code. Yes. How I have done this? You will see that I have the function which set the filter to apply, and I use the NL filter, which by that here I can specify 3 by 3, and then I can plot it. Let us see what is this function. Much more, we want to read much more about NL filter. Okay, simply we can write on that, and then we say that help on that statement. And during my lecture, if today one person helped me to see that which part you can see and which part you cannot see, just type in the WeChat. It's great help. Okay. If you see this help section, it said that it's used the general sliding neighborhoods operation. If you want to read much more about this, you can go to the more descriptive, but now I just opened a small help for that. In that, you can do some median filters to the image, or select and slide your filters on the image. How this function is arranged is like that. You can apply the function font to each m by n sliding block of the grayscale image, means that it's mainly work on the grayscale image. And in the second form, even you can use the indexed form. I just use the first form of this folder, this function, as the NL filter, A, M, N, and font, and then use it on my cameraman image. Nice thing maybe here, if you use some color pictures, this will not work. It mainly work on the grayscale image, means that for the color image, first you should convert it to grayscale, and then you can maybe apply this filter on them. That is one thing that I tell you already, that if you want to test the image on the MATLAB, try to use different inputs and learn something from that. Here, as you can see, we have the function of func, which is as the maximum filter function to apply over the every 3 by 3 neighborhoods of the image, and this replace every input pixel in the output image with the maximum pixel value of the input pixels of neighborhoods. You may also wish to experiment with the effect of varying the neighborhoods dimension. Then in the MATLAB min and max, you can do for that and type the different value in our function. Means that 3 by 3 also can be changed. Let us change that and see the effect. Okay. Um, I think if you see just the codes now. Okay, can you see the code now?
Yes, sir. We can.
Okay, okay. Please just type in the group if you can see the code. Code is okay. In our DIP code, I think you do one thing. Awesome. Please, you give me the feedback in WeChat, in private WeChat. We can see that if you couldn't see any part. Anyway, in this code, see, we have 3 by 3. Let us change it by 4 by 4. And now see the action. If I evaluate it, oh, pictures become more disturbed. See the result? Okay, what will happen if I put it 10 by 10, this much big? Test on that. Okay, if you see the image now, you will understand that we kill the image. See? See, the image is die. And now we don't have proper image. Okay, what we should then, it's tell us that if you want to do the good filtering on that and don't lose the image, maybe you should change the value of your matrix. Now I put it to 1 by 1. Again, I will share with 1 by 1. See, this is my 1 by 1. Can you see that? Here, what will happen? The image quality is somehow not disturbed much more, and maybe we didn't do even much more effect on the image. Okay. Then what we learned that these 3 by 3 and selecting the dimension of the neighbors will help you to first of all do some action on the mobile, and then do some action on the image. I saw my mobile meanwhile, and then it has the more critical effect on our image size. The other thing that I wanted to talk is the filter kernels and the mechanism of the linear filtering. I talked today about the kernel and the convolution for you, but better convolution representation in MATLAB we will have in future, but now as the rough idea, just having it. Linear spatial filters is the new or filter value of the target pixel is determined as some linear combination of the pixel value in its neighborhood. Any other type of the filter can be defined by a nonlinear filter, and the specific filter, a specific linear combination of neighboring pixels that is taking is determined by the filter kernel, which people will call this kernel as the mask. Let us test one filter mask or linear filtering on one image in another code that I have here. First, let me show you my code here. Okay, now I think you can see my code. If you can see it, I will describe it here. First, we have 3 lines of CLC, clear R line, closed line, which is the fixed part. Then I use some image, suppose some Pepper's PNG file, and then I'm going to show it. Okay. Then based on that, I take the 5x5 convolution kernel, okay, with the help of f special function. And then I will use the symmetric mirroring at the edge, which we talk. The edge is very important today. We talk about it. And then I'm going to apply on my image. Let us see the result of this code on our MATLAB side. Oh, it's come. See what will happen. The whole pictures become blurred, and somehow we uh, kill the image. Maybe some of you tell me that, what is this? You just disturb the image. I say, no, wait. These are some pre-processing job. These are some pre-work that after that we can have some other algorithm which help us to searching for some specific target in our image. Remember then that. Here we are specify the f special function to construct the kernel that will mimic the effect of motion blur, and uh, from our earlier discuss, it used the deal with image edge during the filtering, and you may wish to even do some better job in the side of the image, then you can change and work with the function value that we have here. It means that about the IM filters and type of the work in the IM filter, um, you can more and then see the other result. Um, I teach you, but once more, we will test on IM filters part. If I put the yes, let me take the help on the function. Problem with this MATLAB is that always I should run between the windows. Yes, here you will see that this is the ND filter, and yes, I don't know. Can you see the help part? Okay, let me see. Maybe we can. Okay, can you see the help part now? I think maybe it's better. I found a way. Okay, good. Thank you. You will see that I have the function of IM filter, and in that we can filter the multiple array with the dimension filter here. There are some examples like what I use, this purple job, and then if we use the blur of that, you will see that it will come. And then by changing the difference means that the type of the boundary here, if we use the replicant, output is this. And if we use the symmetric one, we have the output like the work that we have done here. And in this image, even you can do more filtering part, means that filter image here. And then you can see, I think this document is not bad for you to read. And any, I think, task that from this time I will give you, try to read the function of that. Even I think for the end of this week, I will give you one specific task that you should list the name of the function that we learn till next week and give the short description for them. But now, just hold on. We will see. Okay, then if Roy, it's okay now, you should see my desktop. Can you see my desktop? Okay, good, good. Then now I learned how to work with MATLAB, and that also, that was really difficult. Anyway, another thing is that we actually, why we use the filter, we have some aim for maybe detect the job, or we want to remove some unwanted signal on the any image. Here is the filtering for some noise removal. And one of the primary use of the both linear and non-linear filtering in image enhancement is for noise removal. Now we investigate the application of number of different filtering here from this part for removing the typical noise, such as additive salt and paper and Gaussian noise, which I um, give you the theoretical part, I think, 4 lectures before. The result of noise addition from the example are shown in this figure, and this image will, from the basis of our comparison of the noise removal, let us test the code for this noise removal, and then we can talk on that. What I try to give you, I try to give the code with the comment here, as you will see this green line. Then if you just read my command also, can understand it better. Even that one by one I test and put in my PPT. I didn't copy paste from any place. But I try to give you the more comment regarding this image. Okay. Now, see, this is the image that we have. And then based on this image as the original one, I add salt noise on my figure. See, compare the second one and third one. But how it will happen, it's come from this part. See, first part CRC clear closer is okay. After that, reading the picture's name is okay. I subplot it and show it, it's okay here. This is the type of the filter that I put, salt and pepper, and we use 30%, 3% of salt. And then we display it and add, after that, I use some Gaussian noise for that. First, I use some salt, and in the last one, I use the Gaussian noise of 2% or variation of 0.2, 0.2, and then show it. Now, let us once more see the result of my image part. Here you will see the Gaussian, there is more noise here, but little bit it has the nice arrangement for the noise. But in salt and pepper, it's exactly like a salt on my image. See the result on my image. Can you see these photos and output from MATLAB clearly?
Yes, sir.
Okay, good. Well, then we find how to work with this. Anyway, we use the IM noise function here to add the salt as well as Gaussian noise as the input image. And the strange is specified using the percentage density and variance with these two functions. And there is also some other jobs that we are going to follow here, that after this filtering part, one more filter which is more usable is mean filtering, which is perhaps the simplest linear filter and operates by giving the equal weight of to all pixels in the neighborhoods. A weight of the WK as the parameter of this type of the filtering is 1 divided by n by m, which is m and n are the neighborhoods which has to effect of the smoothing the image and replacing every pixels in the output image with the mean value of n by m neighborhoods. The weighting scheme guaranteeing that the weights in the kernel sum to 1 over any given neighborhood size. A mean filter can be used as the methods to suppress the noise in an image. And another common use is a primarily processing step to smooth the image in order that some subsequent processing operation will be more effective. Then we know this type of the filter as the primary part for our job. Now let us see the action on the previous image that we have. What I have done from now, I will show you the previous step and next step of it. Let us change this. I will do. See, CLC and clear is same. Then I open. Then here I add 3% of paper noise, same as first one. Then I use the Gaussian. Then I will use test one. Let us see test paper and Gaussian. Say example one. Let us see it will work or it will give error. Most probably it should give error. Okay, nice. Because I have the problem for this part. Now, let us run it. Yes, figure name cannot be the name. Okay, I put figure one. Then it should work now. No, I don't want to waste time for searching the name of function. Okay. Now what I expected. Figure one can be the previous noise that I have. And filter figure two should be the mean filter that I have. Okay, type of the mean filter. How I do the seed setting means that after applying the salt and paper image, and then after applying the Gaussian image, then I need to run it. Let us see the difference between these two images. Yes. Now we will see. After having it, this one is first after adding the noise. This is the paper side, but this is after using a mean filter. You will see that it's become more smooth. And this one is after adding, means that figure one, it's after adding the Gaussian noise, and this one is the mean filter action of that. Again, you will see that it's become more smooth than the previous job. Okay, one more filter is median filter, which is another commonly used filter. And these times overcomes the main limitation of the mean filter, which is at each pixel is address, and it's replaced by a statistical median of n by m neighborhoods filter and the mean. The median filter is superior to the mean filter in that it's better and preserving sharp high frequency detail. For example, edge part is much more important. Wireless eliminating the noise, especially isolated noise sparks such as salt and paper noise. Let us see the result. I claim that I should have the better result for this median filter than mean filter and on the noise which I generated. Now let us see. I will put the figure one as my noisy picture, filter two as the mean filter, and filter tree, picture tree as the median filter. Now let us see. Okay, 1, 2, 3 pictures are come. Let us now gather them together. First is noisy picture. You will see. In second, it's little bit improved, especially salt and pepper one is good. Gaussian BART is also okay, it's improved. But now you will see these median filters. In the median filter part, you will see salt and pepper one. It's become fantastic. And now somehow we can say this Gaussian filter one, Gaussian noise one, it's become little bit near to the salt and pepper part. You see the act of the filter. Now compare first one, last one, first and last. See, this is the effect of the filter which we generate on our image. Now, one use is that you have one picture which is it's noisy picture. You want to remove that noise. Simply this function will work and make the smoothness to your image. But what was the benefits and what did happen is that this filter work on the edge kernel and the neighbors of pixels better than the previous filter job. Let us continue more about this topic. Okay, median filter we said. We can have one more filter which we call it rank filter. Rank filter, uh, as you see, median filter is really just a special case of generalized order rank filter. The general order filter is some type of nonlinear filter which comprising the following command. First, it will define the neighborhoods of the target n by n, then rank them in accessing the order. First is the lowest n by n and its highest value. Then it will choose the order of the filter from 1 to n and set the filter value to be equal to the value of the chosen rank filter. Let us again check all filters that we have till now and see the result. As I put close and CLC and clear all, then I don't need to close all my previous figures, and just running this code with that mentioned line, it can close them and then reopen them in the proper way. Let us see. Figure 1, 2, 3, 4. Yes, figure 4, which is the rank filter, will come. Now we can compare with the median filter and then with the mean filter and with the original image. Let us just compare the original one, and with the original one you can see little bit something happened in the Gaussian one. In Gaussian, it can eliminate the background. And now maybe if your job is for this image counting the number of coins in picture, simply you can follow that and see the result. See the result. Yes. Okay, we'll continue. Of the image filtering job, which is the target for today. This we have defined 5 by 5 maximum filter and apply it to the three image generated in example and show finger. Experiment with using the larger neighbor size for this filter, varying the rank of the filter, means the second parameter of function of ORD field, and the effect it has on the resulting image. Let us check even this rank filter output, which is here. Here we have 5 by 5. Let us make it 8 by 8. 8 by 8. Yes. Once more, I will run it. Yeah. Okay, 1, 2, 3, 4. See. Fantastic. What will happen? Number of that is increased. Now compared to the first one, compare first one and last one. It's become much more nice. Okay, what will happen if I put it 10 by 10? Yes, run it. Yes. Exactly nice thing happened here. You see that in the compared to the first image, now in the last one, it gives the border for you. This border is happening by this rank filter. And as we say in the kernel on the image, we should be careful. Okay. Then when we increase the number of kernel dimension, it's exactly work on the edge of my image. Now that is why I have this nice border. Huh? It's nice. Good. One more thing that today we are going to do is the Gaussian filtering that we discussed mathematically in lecture number, I think, 4 or 5, which in that it's one of the very important and on theoretical and practical reasons this filter is very important. Here we filter the image using the discrete kernel derived from the radially symmetric from the continuous 2D Gaussian function. And here is the formula of this type of filter. If we want to test it, I think here because the number of line was more, I just focus on this type of filter. Let me run it here, yes, and then run. Well, I just here open the image after filtering. You'll see that there is much more smoothness here. And this filter also is working very nice for us based on our target, which is the doing the filtering on image. Okay, that was some type of filters that we saw and we tested. Just some of you maybe tell me that why we are not working on the um, colored image. Just I bring one example about this color image and a test on my photo. But don't forget one thing, for the color image, we will have much more work. And maybe some of these function means, suppose, if you want to work with the convolution statement or function, image in the RGB form may have the problem. Let us check this example, which in that I teach you how even to convert to RGB level, uh, change the RGB level of image. Yes, we run it. You can see at this, okay. APG error unable to open. Okay, let me see, maybe I change my image. Okay, one thing I forgot to do here is that CLC clear all, yellows all. Now I'm going to run it, suppose till here. I want to know what was the error. It's not even bad. Some of you have problem. Run the first part. Okay, opening, then adjust image to Binary, okay, it's come. Okay, then let me run it once more from first. I think the problem was some conflict between the parameters. Because I had the result, I didn't. Okay. It said that IM info it cannot give. Yes, this is for this part. Yes. Maybe even now we can test this. Okay, IM info function has some error. What should I do? Simply, I will help on selection. Is that read the function to see that what is the problem. See, IM info and file name. Okay. Even see, there is lots of nice example that we can check. Okay. If just I take the IM info, what will happen? Okay, it said that is wrong. Okay, okay. I should give it the name. Suppose I will say y is equal to this. Let us see. Unable to open the file ATA. Okay. What about ATA 1? There is some problem regarding my reading the image. Okay, just eliminate these two parts. Rest of the part I will run, and then I will try to solve this problem for you later. No, because I don't want to waste your time. Okay, now it should run. Yes. It gives me the histogram of my image. It changed it to the binary. It changed it to the grayscale level, uh, as well as shows that adjustment of the intensity of my image. That is very a small program that I tell you I want you to test on MATLAB side. It's not bad experiment.